Alright, tonight I'm going to show you how to calculate power, which is really straightforward. The equation's right in front of you. Power, or P, equals work over time. Work has the unit joules, as you know. Time has the unit seconds, and power has the unit watts. So when you talk about like the wattage of a light bulb, you're talking about its power. Calculating power, very simple. Power and work are both scalars, so you don't have to worry about them going in different directions and crazy things like that. The only hard part might be calculating the work, because if there's a force involved in finding the work, you do have to worry about the direction of the force for F cosine theta times the displacement. So finding work can be difficult, but once you're able to find work, those kind of situations go crazy, but then power is very straightforward. You just divide by time. All right, so here we go. A 10 Newton box is lifted 2 meters onto a shelf in 2 seconds. 2 questions to answer. First, how much work is done? Well, if we draw a little diagram, we lift our box with 10 newtons of force, and the amount we displace it is 2 meters, and we lift it onto a shelf. So those are both up 2 meters. And since those are in the same direction, my work is going to be positive. So now let's calculate the work. And I think I have enough room over here in the margin. Work equals force times displacement. No angle between those two things. So work equals 10 newtons times 2 meters. Work equals 20 joules. Okay. And now how much power is dissipated? Power equals work over time. We just found the work. Power equals 20 joules. The question gives me the time, 2 seconds. Over 2 seconds equals 10. And the units for power are watts. All right. I don't know if I said much about it on the last slide. Let me go over this one more time. Power, the units for it are watts. Work, the units for it are joules. And time, the units for it are seconds. And just to be clear, 10W is 10 watts. And that could get confusing, so it's not 10 times the work, it's 10 watts W. Okay, and that's really all there is to it. If you can find the work and you can find the time, power is very straightforward. Finding time could get complicated. It could turn into a kinematics problem where you have to solve for time. You can definitely count on things like that happening. Finding work could get complicated because your force could be at some crazy angle, and you can definitely count on things like that happening. But then once you've got the work and the time, you just divide to get power. And that's it. Last thing I want to leave you with in this first video, a quote over here from a New York Times article, which actually might mean something different now that Lance Armstrong has been implicated in doping. But Armstrong can ride up the mountains in France, generating about 500 watts of power for 20 minutes. So this is to give you an idea of what a watt is. Something a typical 25-year-old could do for only 30 seconds. A professional hockey player might last, that is generating 500 watts of power, about 3 minutes and then throw up. So 500 watts of power for 3 minutes would cause trying to generate that power with your body, would cause a professional hockey player to vomit. Over here on the right, I have some things you might know about, and then how much power they generate. So Hoover Dam, which is a great big dam that generates power through water, through spinning a turbine, generates 1.34 times 10 to the 9th watts, so a lot. A car going at 40 miles per hour generates 7 times 10 to the 4th watts. A home stove, 1.2 times 10 to the 4th watts. So that's 1.2 times 10 to the 4th joules per second. It's a lot of energy every second. Sunlight falling on 1 square meter of the ground generates 1,380 watts. A refrigerator, 615 watts. A television, 200 watts. Walking up the stairs, like I just did to get to where I'm making this video, 150 watts. And your brain, 20 watts. So every second, your brain uses 20 joules of energy. And 20 joules for every second would be 20 watts. So some typical things just to give you an idea of what a watt is. That's all. and one more video helping you review units, since there have been a lot of units so far in this unit. Haha, I made a funny.